Welcome back to the Foundation in C# course. We are currently in Module 7, and this lesson we're going to be covering unit tests. And unit tests is something that can be very scary at first, but once you've gotten to know it and gotten to understand it, you'll see the benefits of unit tests, and unit tests aren't scary at all. So let's go right to Visual Studio and start looking at a project. So we're going to start off by creating a new project. And let's create a C# project, a library type, and let's grab a .NET Standard class library. This is what we'll typically be using. So let's select that and hit Next and call this our demo library. I'm calling it library because I want to indicate that this is a class library. So this is our demo library, and we're going to call this Unit Test Demo App. And we'll hit Create. Now once this gets created, we'll have our class library, which we can delete class 1. And we're going to create just one class in here. The point is not to create a class library. The point is to work with unit tests. I'm going to hit Add Class. And let's call this our display, if I can spell right, display message class. Or display messages class. And make it public. And then inside here, I am going to create a public string, and let's call this the greeting. And we're going to pass in the first .6 p.m. That would be 18. So it's less than 6 p.m., then say good afternoon. But once 6 p.m. hits and from then to midnight, we're going to say good evening. No matter what, we're going to return output. So now we have our one method that what it does is it creates a greeting based upon the time of day. And this is in a class library. We don't have a user interface yet. So how do we test to make sure this code is right? Because one of the things that you want to do whenever you're writing code is you test your code to make sure it does what you expect it to do as quickly as possible. For instance, if I hadn't caught that, I was thinking, in the United States, we do AM and PM. So AM from 1 to 12 and then PM 1 to 12. And so I was thinking 6 PM. But if you look at the logic of that, that wouldn't work. And my code wouldn't work as intended because less than 12 gets this message. So the else if here would never be less than 6 because it would already have run this code instead. So it never would have run this code. And so I didn't think about that because I was thinking AM, PM in my head. So what I had in my head, what I was thinking, didn't come out quite right in the code. Therefore, my code would not have worked. But how do I know that without running my code? And the answer is I really don't. I have to test my code in some way. And if you have not used unit testing before, the way you test your code is you have a user interface and you run this code. And maybe you run a little bit of sample code or something like that to call this. And you just say, let's just call this and see what happens and make sure it does what we expect it to do. And if it doesn't, we go, oh, you know what? Oops, I see the problem. And we change that. And now it works as intended. But what if we hadn't tested the afternoon code? We'd tested just the morning code. And it worked. Well, we think it's great. We launched this to production with a bug in it. And so we find that bug and go, oh, we got to test the afternoon code. And we fix the bug. And then we destroy that test code because it's not part of our real application. So how do we make sure this code is always right, even if we make changes to it? Well, we have to create a new way of testing this again when we make changes to this code. And that's a pretty fragile and time-consuming process, especially since we may not always test all the different circumstances. This is a very simple method that even so has 3 different branches to it. So based upon the time of the hour of a day you pass in, you can get one of 3 different results. So unless you're testing all 3 avenues, then you don't know if it's working the way you intend or not. And it may be you have to test more than those. Maybe you should test every hour of a day because you might not get what you expect back from a certain hour of a day. Maybe you expect afternoon to go until 6 p.m., so including 6 p.m. So if you pass in 18 for 6 p.m., then if you get back good evening, that's not what you intended. So these are all things you have to think through. And if you're keeping some kind of test application where you're kind of building some sample code to run this and try it out, that's just messy. And that's where unit testing comes in. Unit testing, the entire purpose is to create a test application, a test method that will test this method and that can be rerun over and over again. And then as you get more, may you find that bug in the hour a day and you realize we weren't testing afternoon. And so you write more tests for this method. And the result is you now have all these tests you can run against your code whenever you want. So whenever you make a change, you run all those tests. And if all those tests pass, then the method still works as you expect it to. If they don't all pass, maybe you have a bug in your code. And the cool thing is you don't have to have a user interface in order to run these. Or at least you don't have to build one because you already have one. It's Visual Studio. Visual Studio can run unit tests right inside Visual Studio and tell you if your tests are passing or not. So let's build a unit test project and see what it looks like and see how it works. And we'll talk more about what unit testing is. So let's right click on the solution and say add project. Now right now I have C# library. Let's clear out library, so all project types, but I still want C#. And I want a unit test. In fact, I want a specific type of unit test, but first let's look at all unit tests. So unit test like so, and there's a unit test project for MS Test, and that's for .NET Framework. There's a unit test for Universal Windows, or UWP, and that's for MS Test. And there's a .NET Core for MS Test. And then we have other kinds as well. We have XUnit .NET Core, we have NUnit .NET Core, and we have others. Which one do you want to choose? Well, MS Test has been the tooling that kind of lags behind NUnit and XUnit. And it seems like it's always trying to catch up to those other projects. MS Test comes from Microsoft. It's built right into Visual Studio. NUnit and XUnit are external projects that are open source and they're community driven. And so we get to choose which one we want. Visual Studio now supports all three just the same. I mean, it's no different really. My personal preference is XUnit. It just seems like they are in the front when it comes to new features and ways of using unit testing, and the third-party integrations with XUnit seem to be fairly high. So I'm going to choose XUnit. If you decide that you want to use NUnit or MS Test, you can do that. The only real differences in the majority of how the testing works, the differences will be in the syntax. There are some edge things that MS Test might not do at all, and NUnit might do differently. But for the majority of things, the differences are syntax. Like I said, MS Test has been catching up. But let's choose XUnit test project .NET. tests. Now, if you notice, we have a project type called demo library. Well, this is the tests for demo library. And that's how it lines up. And so this unit test project will be for the demo library class library. So we name it .tests. Hit create. And it creates for us this project type. And if we zoom in here, we'll notice that it looks similar. We have normally a C# in a green box, but down here we have the half-filled beaker that is green, indicating that it is a C# unit testing project type. And it creates for us unit test 1.cs. That's our kind of like class 1.cs for a class library. And we can either delete it or we can rename it. I am going to delete it, but I'm going to leave it for now because I want to have kind of this demo structure for us. The only really thing that we want to see in here is the fact that it has fact, but I want to leave us here just for our references, just for a minute. So right click on your project. public void test1. We're going to create public void, and our test name is going to be greeting should return good morning message. And that is a long name. Now, why did I call it this? Well, the first part seems kind of obvious. We're in the display messages class. These are the tests for the display messages. And we're testing out the greeting method. So it starts with greeting. But then it says should, and it has what this should do. It should return good morning message. So what do you think this test is going to be testing? Well, it's going to be testing to make sure that when I call this with a morning time range, it should return a good morning message. And we're going to set this up as a unit test, because right now this is just a method. It's just a method in a class. But once we do this and say fact on top of it, we control dot to add our using statement for X unit. Once we say this is a fact, what that's saying is this method right here is a test, and we're stating it should be a fact. And a fact we'll get into in a minute, but essentially it means we're not passing in any parameters. It just is what it is. It's testing one thing. So how do we write this test? Well, let's start by creating a reference to our demo library. Because right now, demo library.tests, it can't see demo library. We got to right click on our dependencies, add a reference, and select demo library, just like you would in a user interface. So now we have a reference to demo library. We can say display messages equals new display messages. And then from there, we can say messages dot greeting and pass in information. So we pass in Tim, and the hour of the day is, let's just say 2 a.m. That should return a message that says, good morning, Tim, according to our code right here. Good morning, Tim. Now, if we do it like this, we don't really understand what's going on or why we're doing it. There's not really a pattern here. And we don't have a whole lot yet, but let's talk through the pattern of unit testing. And that pattern, I'm going to put it, let's put it right at the top. And the pattern is that we need to arrange, then act, then assert. Those are the 3 steps to any good unit test. Now, it may be you don't have much to arrange, or it may be that you don't have much to act upon, but in general, we'll have these 3 steps in this order. So let's talk through arrange. So arrange starts off with, okay, we're going to declare the instance of the class. Cool. The other thing we want to arrange is we need to have what do we expect the value to be. And that's going to be the string. So the expected is going to be equal to this message. In this case, it's going to be good morning, Tim. Now, to be capitalized M over here, we did not. You may wonder, well, Tim, aren't you cheating? Because you went over here and looked at what the method should do. No, I'm not cheating, because that's what this message should look like. Does it? We'll find out. So expected is a keyword that we use. So normally a keyword is reserved. We don't use a keyword. But this is more like a standard word we use. And let's put this in a comment up here. So we have the expected and the actual. Okay? And you can probably understand just by reading those what those 2 represent. And that's why we use those specific names. We have the expected value, and the actual value. So our range is to set up our connection, our instance of the display messages class, and to set up the expected value. Then we have our act. And this is where we do the actual work. So we can say string actual equals, because remember greeting returns that string. So now we have what we expect and the actual result. So you pass in Tim and 2 a.m., then we should get back good morning, Tim. That's what we think is going to happen. And let's talk about the last step, which is assert. And assert says this is what we expected, and it should be the same as actual, or this should have happened, essentially. That's what assert says. Assert is saying this should have happened. And that's why we named our method should. Because this is what we're expecting, so therefore the greeting should return good morning message. Well, this is the good morning message, and that's what it should have returned. Did it? Well, we can say assert dot equal, and then we have two values. So notice there's 9 overloads. We have strings, date, times, decimal, double. Well, if we pass in the type, we can say, and notice also, let's go back to string, expected, actual. Those are the names that Microsoft calls them as well, because that's a common name to call these. The benefit of calling ours expected and actual is we know what order to put them in. We don't put actual and then expected. We put expected and actual. And that's it. So now we've written our very first unit test to make sure that we're getting back a good morning message when we pass in the value of 2 to our, and Tim, to our greeting method. Let's see if this is actually true. By the way, we're done with unit test 1. We just needed to see that fact and this structure. Therefore, let's delete this. So yes, we want to delete this. I just want to keep that around just for a little bit to show you that's what it was. So how do we run tests? We have this thing called Test Explorer. And it just closed on me. So if we go to View and go to Test Explorer and open that up, we can pin this, and now we can run this test. Notice it says we have one test, and it's the display messages test, and the greeting should return, and it's going to kind of scroll off the page here because we've got to open it up. But that's our unit test. Now notice also, if we zoom in here, I can see as little, it's very, very tiny, this little blue icon that indicates the test has not yet been run, but it's new. So let's come up here. We can run all tests or run selected tests. I'm going to run all tests because there's only one. What it's going to do is it's going to compile our application, it's going to build it, and then it's going to run our tests. And now we get these nice green checkboxes that indicate that yes, our test passed. And if we click on this, it tells us more information about our passing test. It says the source, the line, it should return a good morning message, and the duration was 2 milliseconds. So it ran that one test. Now this gets into a tricky area, and that is the idea, and you've probably heard about it, and if you haven't, you will at some point soon, and that's the idea of test-driven development, TDD. And the idea behind test-driven development is a pretty good one. The idea is that we write our tests first, before we write our code, because that forces us to define what the inputs and outputs should be of a method. And one of the benefits of doing so is, imagine for a minute that I made a mistake in this test. Let's just comment this out. So we're not actually going to run our code, but instead I'm going to say string actual equals good morning, Tim. Do you see the problem here? I'm not actually calling the greeting. But if I were to run this code, and it just is running now, and it turned green. The test passed. Because expected and actual are the exact same thing. But that doesn't mean we actually tested our code. And so test-driven development says you might write a bad test. I mean, it's just code, and we make mistakes all the time. So you might make a mistake in your unit test where my failed. We expected one thing, we got a different thing. Now, if I write my code to make this method pass the test, if I write this code and then I run my test, it should turn green. And if it does, and it did, then I know two things. One, I know my code is correct as far as I've tested it. But two, I also know that my unit test has been written correctly, because my unit test will only pass if I have written it in a way that fails first and then it succeeds when you write the correct code. So that's the idea behind test-driven development. The question's going to come up, should I do test-driven development versus should I write my code at my tests afterwards? I am not nearly as uptight as some people are. I don't mean uptight in a negative way. I mean rigid, as in this is the way you do it and that's the only way. Some people are that way and I respect that. For me personally, I am much more in the mode of write tests. And if that means writing tests after the fact, if you're more comfortable with that, if that seems to work better for your brain, then do it that way. But the most important thing is that you write tests. Now make sure those tests do in some way fail and then succeed, or at least make sure they would fail if you gave the wrong information. Okay? So it does take a little more work to write a test after the fact. But don't let that stop you from writing tests. If you have an application already and say, man, it's too late now. I can't do test-driven development. No. Write the tests. Maybe don't write every test and spend hours and hours and hours writing tests. But whenever you find a bug, write a test to check that bug and to verify that bug happens. And then when you're verifying that bug happens, then fix the bug and make sure the test goes green. That way, in a way, you're doing test-driven development. You're writing a test first, and then you are writing the code fix to make your code work the way it should. And your unit test is saying, yes, that's true, it does work. Now, the other pushback I get on unit testing or test-driven development, either one, is the idea of, man, this is just too much work. I am writing too much test code and not enough real code. And so it's slowing my development process down, and therefore I'm going to dump unit testing and just write code. The problem with that is that, yes, you can get your application out the door faster with unit testing not in place. Just by writing your actual code, for example, we'd be done already and be out the door. Whereas if we're testing this, we've got a lot more work to do. But the difference is that when you're writing tests, you're making sure that your code does what you intend it to do. What do you think that finds in the process? It finds all of your bugs, or at least it finds the majority of your bugs, because you are saying, I expect this, and I'm not getting that back. Back to this example here, I had 6. When I write, and let's leave this, because right now, if we run this test again, the test will pass. So it's running and it's passed, because we're testing good morning. Now, we send it to production and people say it never says good afternoon. Well, we could write another test. Let's copy this entire thing and paste it, but this time should return good afternoon message. So they've said that, hey, you know what? We've got a problem. It's not saying good afternoon. So we say, well, let's try this. Let's put for 2 p.m. That's 1400 hours. Now it should say good afternoon, Tim. Let's just verify that it says afternoon. It does. So we're good to go. Let's run this test and make sure that it works. And no, we've got one passing test, the good morning test, but we have one failing test, the good afternoon. Notice in our window down here, it says expected is good afternoon, but actual is good evening. That's really odd. Why does it say good evening? Well, if we look, if it's less than 12, well, 14 is not less than 12. Therefore, it goes to the next one. Is it less than 6? No. Therefore, it goes to this last one, which is good evening. I say, oh, that's a bug. Let's go ahead and fix that bug. That should be 18. Now let's run those tests again. And this time when the tests run, we'll get all green lights, because now our application is returning the correct values at the correct times. This is what's called red-green refactor. And this is part of test-driven development. Again, you don't have to go full test-driven development to get the benefits from unit testing. But in the idea behind red-green refactor, let's put this at the top just so you have, again, this documented. Red-green refactor. The idea is that first you write a test that turns red, that's failing. Then you do whatever you need to. You write the code you need to turn that light green. Now, in test-driven development, what they would say is if the first test you write expects you to return good morning, Tim, then just say good morning, Tim. Don't even use a variable. Just be simple. And then you write more tests and you write to fix the code to be even better. I don't prescribe to that detail level of let's intentionally write code that's too simple, but at the same time, it does have some merits. But the idea is we write our test first and make sure it fails. Then we change our code or fix our code so that it turns green, but just enough to make it turn green. Like in this case, we just changed this. But then we can refactor our code. And by refactor, that just means make our code inside this method better. So if there was a better way of doing this, we could make changes to our application. So if I wanted to switch over to a switch statement instead of 3 if, else statements, which it probably wouldn't be ideal because I'd have a switch for each hour of the day. But if I wanted to do that, I could do that. I could comment out this code, put a switch statement in. Why could I do that? Well, because I already have unit tests against this code. The unit tests only care about inputs and outputs. So if you pass in 2 and it comes out as good afternoon, Tim. So you pass in Tim and 14, and it comes back with good afternoon, Tim. That's all it cares about. It doesn't care if it's a switch statement or if else, or whatever else you want to do. The benefit here, and one of the huge benefits of unit testing, is it gives you the opportunity to feel comfortable making changes. If you were a brand new intern that had never written more than demo code in your life, and you show up at a company that's got this massive C# application and they say, change the greeting to make it better, how scared would you be of getting it wrong? Because you're not sure how the greeting is called or who's calling it or when it's called or what's happening. But if you had unit testing and you were sure that all the different test cases were touched, then how comfortable would you feel? Because if you make a change, go, you know what, I think we should do this instead, and it turns some lights red, you go, oops, that's not right. And so you change it back. And you make a different change and the lights stay green. Now you know that that different change hasn't affected the output. And then you can just worry about the code inside this method. And you're not worrying about the entire big picture. It makes you much, much more comfortable making changes. And if you're more comfortable making changes, then you're more comfortable improving your application. You're not nervous that your application might break because you'll know right away if it broke and you can fix it. So that's the benefits of unit testing. Now let's test this method a little more. Right now we have one for good morning, one for good afternoon, but it seems like we really need about 24 from 0 to 23 to test all the different options. That would be exhausting, writing all of these for the different expectations. So let's do this instead. We're going to use a different feature of XUnit, and that is the I'll show you. Let's copy this entire thing, paste it down here, but we're going to remove this expected. And instead of passing in Tim, we're going to pass in first name. And instead of 14, we're going to pass in hour of the day. Now, this code can be run for anything. We can call this with John or Mary or Sue. We can call this with 0 through 23, and we can know what we expect the values to be. So with this, let's return, or let's pass in some data. So again, square brackets, inline data. Now with XUnit, you can have inline data or you can get data from somewhere else. But I find that the simplest way is just to get inline data. So let's pass in our 3 parameters. Let's start with Tim, and then the number, let's start with 0, and it should say, good morning, Tim. So those are the 3 parameters. Tim, it's 0 o'clock or it's midnight, and it should say, good morning, Tim, because technically midnight is the next day. If we run this, notice we have one more test here. If we run this, let's see what happens to this third test here. It turns green. But watch what happens when I copy this inline data and I paste it again. But this time I put a 1. And I'm going to paste it again and put a 2. And I'm going to test every single case all the way up through 23. I'm going to pause the video because there's no reason for you to watch me copy and paste over and over and over again. Okay, I think I got them all done now. So now we have 0 through 23. I just used Tim for all of them. And so you have good morning, Tim, all the way down until we hit noon. And then it's good afternoon, Tim, until we hit 6 p.m. where it says good evening, Tim. Now let's run this again. And let's see what happens to our unit tests. Notice it now says up here, let's zoom in, it now says 26 tests. Even though it only shows 1, 2, 3. But right here, it's really small. There's a little arrow. So let's expand that out. And we'll see that actually there's a whole bunch of tests here. And they're all success because these are all successful. So now we've written 23 tests, but only wrote the code for 1. Because we passed in the values and the result we expected. So this is what we expect, and these are the values that create that expectation. Now, what if we said, you know what? We actually should say something totally different for up through, let's say, 4 in the morning. So for midnight through 4 in the morning, we should say, go to bed, Tim. How about that? Because Tim needs that reminder. So let's just change our tests. Tests that failed. Notice they're not in order. And the reason they're not in order is because it runs the tests in parallel. It does not run them in order synchronously. It runs them asynchronously. So it's expecting this and it's getting that for each of these tests, and it tells us which ones. All right, let's go to our code. And we now, if you see right here, for mine, I'm not sure that this is a feature yet for Visual Studio Community Edition. I believe it might just be for Enterprise, but I believe they're trying to push this down to Community, so it might be in 2019. Not positive. But what this is telling me is 21 out of 26 tests are passing for this particular method. So this method has 26 tests associated with it, only 21 of which are passing. Let's see if we can fix this. So what do we need to do to fix this code? Well, if we come up here, my assumption is I say if hour of the day is less than, let's make a mistake and say 4. Then I'm going to say output equals, and let's just copy and paste and say go to bed, Tim, or whoever we passed the name in for. You think that fixed it? Let's find out. Let's run this test, or run all the tests actually, and now it still says we got 5 that are failing. Why 5? Oh, see, we wrote this test, but when we put this if statement in, we never said else if. So the if statement here ran again, and it overwrote our output. So we need to say else if here. Notice how easily that fixed my logic? Because I had a bug in my logic that wasn't easy to see. This test made sure I saw it. Now I've fixed the bugs. There's no more bugs, right? Let's run this again. I run it again, and this time we still have 2 failures. Well, that's interesting. So if the hour of a day is less than, oh, that's a problem, actually less than 5. Let's run this again. And this time we have 25 passing and 1 failure. What's that failure? It's actually down here. We're expecting good morning, Tim, but the actual is go to bed, Tim. Why is that? Well, let's go right to that test. We'll double click on it. And it takes us right to that test. And that's this one right here. Notice the red right here. It's saying this is a failing test. If we expand it out, we'll see that we're passing in 2, which is 2 a.m., and we're expecting good morning when it should be go to bed, Tim. In this case, our test is the thing that's wrong, not our code. And this is something else that people get concerned about. They say, oh, you know what? My tests are so fragile. I have to keep changing my tests as my methods change. And yes, you do. Because your tests reflect your expectations. If your expectations change over time, your tests need to as well. But if you ever have a test that's passing and then it's failing and you think the test is the problem, make sure that code is not already in production. Because if it is, guess what? If you were relying on that method to do one thing and now it does something different so that the unit test has to be changed, so does any code that called the original method. So if I already had code out there that was expecting good morning, Tim, for anything before noon, then I'd have to go change that code in production before I change my unit test. Because my unit test is kind of that alert, something isn't right. In this case, I've changed what the output is going to be for the greeting. And as long as I know that, as long as I've taken care of making sure that change is reflected everywhere and that all my methods have used that new logic or understand that new logic and are expecting it, then I can change my unit test to say, go to bed, Tim. And now when I run this, I should get back all passing tests, and I do. So that is an overview of how unit testing works. There's a couple things I need to talk through. One is the name unit. Unit testing is intended to test one unit of work. That typically is one method. It is not intended to test an entire sequence of things. That would be integration tests or even higher. A unit test tests one unit of work. So just think that one through, and you should have the most in unit testing. If you have those integration tests that test more than one thing at a time, that test kind of the flow of how things work, you'd have less of those than you have of unit tests. Unit tests are the thing you have the most of. They're also the easiest to do and the easiest to maintain. So if you're going to write one type of test, this is the type of test you want to write, is unit tests. Unit tests only test public methods. That may seem weird, because you may think, well, but my private method is a thing that has the unit. Well, no, actually what's happening is your public method, and this is a public method here, greeting. Your public method is a thing that has inputs and outputs. And that's what you want to test, is does this unit, when I give it certain inputs, give me my expected output? And that's what you're testing. You're not testing those private methods. So that's another thing that people often struggle with. And the final thing that people often struggle with, and this is the most complex, and it's not something I'm going to cover today directly, but I do have content out there to help you with this, especially my YouTube channel. I have a video for it. But It's the idea that you should not test your dependencies. Okay? You need to separate out your units and not have dependencies. And what do I mean by dependencies? Well, this is a very easy method. It just takes inputs, it tweaks them a little bit, and sends back an output. That's all it does. But in the real world, you'll find that this type of method is about 2% of your overall methods. You're going to have a ton of methods that are much more complex than this, and they have what's called dependencies. So maybe this method, if it were in the real world, it might be storing this information in the database before it returns it. Well, if you run your unit test over and over and over again in testing, what are you doing? You're storing these messages in the database over and over and over again. You don't want to do that. You want your unit test to be independent of your database and not mess it up. You want your unit test to be independent of your email system and not be emailing customers every time you run your unit tests. You don't want to be texting customers. You don't want it to be deleting data. You don't want to be, all these different things that your methods can do, you don't want them to do. Instead, you just want to test the logic, not the actual insertion into the database, or at least not in this particular space. So what do you have to do? Well, you have to do what's called mocking. And what that is if you had a database in here or database access code where you're writing to the database, you're probably doing that through a class. And so you have this class, let's just pretend, so we're going to say data access DA equals new data access, like so, and then you'd say DA.write to DB, my code, whatever, or my data. That's probably better, my data. So how do you get around this code right here? Well, we're going to cover dependency injection later, and this is where this course and the series of courses kind of builds on top of each other. And so I don't cover everything all at once, and so therefore some things you learn later that apply to earlier things. And this is one of those cases. Dependency injection is the idea that you don't do this line right here, where the new data access, but instead in your class or somewhere you ask for this object. So you pass it in as a parameter. And then what you can do is in your unit test, you can pass in a pretend data access. So it says write to DB, you say, sure, yeah, I did that. And then your method thinks that it worked. But you've been able to test all this code without actually writing to the real database. That's what's called mocking. And so that's a thing you're going to have to do for a lot of unit testing. And that's one of the things that really stopped me when I first learned about unit testing is, this early stuff, these tests look cool and it's simple and it's, yeah, I can do this. I can write that little bit of code and have this test and boom, I'm done. And I get to the real world and go, oh, hey, but how do I do this? And how do I do that? Than we've gone today, and I don't want you to worry about it yet. But I want to tell you about it because when you start writing unit tests, I don't want you to be discouraged by the fact that you can't just throw us into any old application and have it just work. We're going to get there, just not quite yet. So we're learning the first part, and then as we go through, you'll be able to do more and more of this. And like I said, I do have YouTube videos on how to do this in more depth, because this is a foundation course. We can't cover everything in depth, but just hold off for a little bit until you understand more things a little deeper before you get into mocking and other things. That gets a little more advanced. But this is the basics of unit testing, and this is pretty powerful stuff in itself. The idea that you can run hundreds, thousands of tests against your code don't turn red. So it makes life easier. Unit testing, really, really powerful stuff. So that brings us to our tip for today, which is testing is an upfront expense for a long-term ROI. ROI stands for return on investment. So it's an investment, meaning it costs you something up front, but it's a long-term return on investment. And that return on investment is in safety, in confidence, and in stability. Who doesn't want to ship code that has less bugs? Who doesn't want to be more confident that the changes they make don't break anything? These are all the things that unit testing provides for you for that upfront expense of writing a little more code. So I would encourage you to write unit tests. All right, let's go to our homework for this lesson. And the homework is to build a simple unit test project. Don't worry about testing any code yet. Just get the flow down, okay? So just write a simple unit test project, something that maybe you just recreate what I did, but just get that flow down of assert, act. That's wrong. That's better. So just get the flow down for arrange, act, and assert, okay? So just build a simple one. Maybe write just one method in either a class library or even write in the unit testing project itself. Write one method and then test it, okay? And just get that flow down of arrange, act, and assert. So set things up and say what you expect, and then do the action, and then assert, meaning is this true? Is this are these two things the same or something of that manner? Okay? Just try and get that flow down. Really simple. Even if you have to just recreate exactly what I did in the video, do so to make sure that you're comfortable with those 3 steps. Once you're done, come on back for the next lesson. And that one's going to be a mini project where I actually give you the homework up front, and then we're going to do it on video. And we're going to use unit testing in our mini project. Okay? So come on back for that once you have gotten that flow down of creating unit tests.